Let's talk about the chemistry of sulfur and sulfur compounds. Sulfur can act as an oxidant and a reductant. Here is an example for sulfur acting as an oxidant. As we can see here, sulfur plus magnesium will become magnesium sulfide. The sulfur gets reduced to the sulfide ion 0 to -2, while the magnesium gets oxidized from 0 to +2 oxidation state. Here sulfur acts as a reductant as it reduces oxygen from 0 to -2 oxidation state, while it oxidizes itself from 0 to +4 oxidation state. Here are some other reactions. Limited sulfur can react with sodium hydroxide to form sodium sulfide, sodium sulfite, and water, while excess sulfur can react with sodium hydroxide to form sodium sulfide, sodium thiosulfate, a hypersolution of it actually, and water. Let's move on to reactions producing colloidal sulfur. One such way of obtaining colloidal sulfur is by adding dilute acid into the thiosulfate ion solution, in which case we will observe not only a precipitation of colloidal sulfur resulting in a white-yellow turbidity, but we will also observe the evolution of sulfur dioxide gas alongside water. Hydrogen sulfide and sulfur dioxide, they react with each other to form sulfur, colloidal sulfur, and producing water. Hydrogen sulfide also reacts with hydrogen peroxide to form sulfur and water as well. Hydrogen sulfide also reacts with chlorine to form sulfur, precipitate colloidal sulfur, and produce HCl. In these cases, hydrogen sulfide acts as a reducing agent. So that is to say that hydrogen sulfide oxidizes itself into sulfur, into colloidal sulfur in this case, while reducing these compounds to their respective reduced forms. Then we will go on to the chemistry of sulfuric acid. As you can see over here, sulfuric acid can be formed by dissolving sulfur trioxide in water. It will result in producing sulfuric acid and also a high increase in temperature. It's a highly exothermic reaction. Metals, they react with dilute acid to form the salt and hydrogen, and metals also react with concentrated acids to form the salt, the dioxide of the acid, and water. So it is reflected in this case, in which magnesium reacts with dilute sulfuric acid to form magnesium sulfate and hydrogen, while magnesium reacts with concentrated sulfuric acid to form magnesium sulfate, sulfur dioxide, and water. Nonmetals, they react with acids, they react with concentrated acids to form the dioxide of the acid, the oxoacid, the oxide with the highest oxidation state of the nonmetal, and water. As we can see, the water is formed in both. Here, the dioxide of the concentrated acid is sulfur dioxide, as we can see over here, and here in carbon, the oxide with the highest oxidation state is carbon dioxide, which is why carbon dioxide is here. And sulfur, its highest oxidation state oxide is sulfur dioxide. So yeah, it's over here. Carbon plus concentrated sulfuric acid results in the formation of carbon dioxide, sulfur dioxide, and water, while sulfur reacts with concentrated sulfuric acid to form sulfur dioxide and water. Glucose reacts with concentrated sulfuric acid to form, basically it dehydrates the glucose to form black carbon while sucking all the water out. It does so with formaldehyde with formic acid as well to form carbon monoxide and extracting that water. Concentrated sulfuric acid is a great dehydrating agent in organic chemistry. and also it acts as a great oxidizing agent. Concentrated sulfuric acid acts as a great oxidizing agent. As you can see over here, it oxidizes copper from 0 to +2 oxidation state, while actually reducing itself from sulfate to sulfur dioxide. And actually nitric acid also has an oxidizing ability over here, as it oxidizes the magnesium from 0 to +2 oxidation state as well. So keep that in mind as well. And this is the chemistry of sulfur.